All right, welcome to this explainer. Today, we're unpacking something that is completely, fundamentally reshaping how software gets built. We're looking at the exact blueprint used by modern dev shops to integrate generative AI into their workflows. And the kicker here is, they're doing it without sacrificing a single ounce of quality. It's a strict, highly disciplined process called the PBYC method. And honestly, it's the definitive guide to building AI-first software where humans remain fully accountable. So, if you've ever wondered how to safely scale AI in a development team without losing total control of your codebase, you are in exactly the right place. Let's get into it.
Okay, let's dive into this. Think of our agenda today as a strict blueprint, mirroring the exact discipline we're about to explain. First, we'll look at the AI coding trap. Then, we'll unpack the core philosophy, plan before you code. After that, we'll map out the 4 AI surfaces, look at the rigorous 4 human gates, and finally, lay out the non-negotiable laws that make this whole shebang work.
Section 1. The AI coding trap. Let's talk about what happens when things go off the rails.
To understand why this method is such a game changer, we first have to look at the somewhat chaotic state of the tech industry right now. There's this massive temptation to just plug an AI agent into your IDE and tell it to build things. This brings us to a phenomenon the source material brilliantly defines as vibe coding. We've all seen it, right? It's when someone prompts a software feature with 0 executable specifications and absolutely no plan, basically hoping the AI can just read your mind. Actually, scratch that. It's more like hoping the AI builds the entire app while you grab a coffee. When you start without a rigorous plan, you are practically guaranteeing failure. You might get code fast for sure, but you definitely won't get the correct code. Now, what's really interesting about this is contrasting the failures with their incredibly expensive consequences. Look at these 3 AI failure modes. You've got intent drift, where underspecified prompts lead to plausible systems that, well, nobody actually asked for. Then there's context decay. This is where the AI agent just forgets earlier decisions as the codebase grows because it can't hold all that context in its memory. And finally, unverifiable output, meaning there are literally no acceptance criteria to check the code against. These aren't just theoretical risks, they are real, painful consequences for dev teams. Which brings us to the antidote, Section 2. Plan before you code. This right here is the philosophical heart of our explainer. There's a quote from the source that just hits the nail on the head. AI does the work by default. The AI may write 100% of the implementation, but a named human owns the outcome. We have to separate the idea of approval from ownership. Sure, a machine can verify code, and a human might sign a gate to approve it, but an actual, named human must always carry the system. They have to be able to jump in and fix it when the AI is switched off. So the PBYC, plan before you code, sequence is beautifully simple, but man is it aggressively enforced. 1. Specify. 2. Plan. 3. Tasks. 4. Implement. The rule is that any task requiring more than 2 hours of build effort gets a written plan first. No plan, no code. An executable, version-controlled specification sitting in your repository, not the code itself, is your single source of truth. That spec becomes the AI agent's persistent memory, totally eliminating that context decay we talked about earlier. And that brings us to this brilliantly simple axiom. Chat is scratch, files are truth. What this means is absolutely nothing crosses a handoff without a written artifact. A conversation you have with an AI in a little chat window, it's just a fleeting memory. It vanishes. The artifact spine, your architecture packs, your design bundles, your code, that is the actual project. Okay, moving right along. Section 3, the 4 AI surfaces. Let's look at the actual assembly line here. Notice how the workflow is completely segregated into 4 strict roles using the Claude ecosystem. Claude Projects acts as the durable brain. It holds the master spec, kind of like a product owner. Claude Cowork wears the management hats, so your PM, QA, delivery manager. Claude Design handles UI and UX, and Claude Code does the heavy lifting engineering. The segregation of duties here is absolute. The design AI is strictly forbidden from inventing scope, and the code AI is never allowed to guess on money math or skip a gate. They stay in their lanes, period. But look, an assembly line moving at blistering AI speed is incredibly dangerous without brakes. That brings us to Section 4, the 4 human gates. Ask yourself this for a second. If an AI writes an entire application overnight, who actually owns the liability if it completely fails? Who carries the 2 a.m. pager? The answer, for sure, must always be a human. And that is exactly why this method dictates that AI speed must be governed by rigid human gates. Here is the mandatory progression.
It all starts at HG1, the scope lock. You don't write a single line of code until scope is locked. Then HG2 verifies the design and architecture blueprint. H3 is the go-live gate. That's when real users and real money get involved. Finally, HG4 is the handover. The golden rule here? Machines verify correctness, but only a human authorizes commitment. You simply cannot bypass these checkpoints.
And to enforce these gates, the system uses something called the teach-back protocol. If an AI presents a decision and a human just lazily types, "Approved, go ahead," the system rejects it. It's a bounce. To unlock a gate, the human actually has to accurately restate the specific trade-off to the AI in their own words. If the AI detects generic boilerplate, it pushes right back. This completely prevents blind rubber stamping by busy human managers.
We've seen the surfaces and the gates. Now, Section 5, the non-negotiable laws. These are the absolute hard lines that keep the whole operation from collapsing.
So the crucial point is that discipline must be structural. Look at these laws. Test-driven development is mandatory. Tests have to fail first. Furthermore, continuous integration evidence sets a task to done. Humans cannot manually drag a ticket to done. Why? Because a status field a person can drag is a deadline a person can bend. Also, missing data renders as unverified, never as a zero, which is just a confident falsehood. These rules never bend.
Then we have the producer law. Simply put, you don't grade your own homework. No producer verifies its own output. Design doesn't audit its own conformance to the spec. The build AI doesn't verify its own visual fidelity. Even the human managers don't review the architecture packs they authored. This forces a strict, structural separation of duties, making sure that blind spots are always caught by an independent layer.
And when a defect inevitably pops up, you use the kickback loop. If a downstream engineer finds a defective upstream architecture document, it is never silently patched in the code. No way. They file a written kickback upstream. The upstream role fixes the document, relocks it, and only then does downstream resume. This is how you keep a massive 80-file build coherent. Defects travel up, never sideways.
Now you might be wondering, okay, this sounds like a ton of heavy process. Does it actually work? $36. That is the remarkably low, verified cost per ship feature from a fictional but fully worked SaaS example in their playbook called Client Pulse. By strictly adhering to PBYC, avoiding endless rework, and using the right AI models for the right tasks, the ROI is just massive. Extreme discipline actually generates extreme efficiency.
But to pull all of this off, your team needs what the sources call the fourth skill, the skill of judging whether what the AI came back with is actually correct. You cannot offload that. To prove engineers actually possess this skill, this dev shop runs a 2 a.m. test and AI off drills. They literally force engineers to navigate an unseen codebase, trace a failure, and roll it back with the AI completely switched off. It proves human capability is real, not just something people claim to have. Which leaves us with this final, vital question to think about. If your AI agents disappeared tomorrow, or if a critical bug took down your application at 2 a.m., who carries your system? Building fast with AI is incredible, but without the PBYC method, without executable plans, structural gates, and true human accountability, you aren't building a product, you're building a liability. Thanks for joining me on this explainer. Start planning before you code, and I'll see you next time.